7.Mid-Review. We're going to review today all the lessons we've been doing these last few days, including before break. Okay, number 1, 3 sides of a triangle. 3 sides of a triangle are given. Classify as a right triangle or not a right triangle. All right. Before I move any further, make sure you have these type of scientific calculators out in front of you. Every single person needs one. If you don't have one, please come up. I have an extra one up here if you need one, but everyone needs to have one of these out on their desk. The baby ones are not going to work once we get to the rest of the notes. All right, the sides of the triangle are 20, 29, and the square root of 440. Okay, does anybody remember the rule, how we proved if it was a right triangle or not a right triangle? Good job. He has it correctly. A squared plus b squared equals c squared. What is that called? You had it right. Pythagorean's theorem. Now, Brady, I need you focusing. All right. Pythagorean's theorem. It does not matter which one's A or B because addition is commutative, but your C does matter. So what do we know about C? Smallest side or biggest side? It's the largest side. So, but largest side. 29. Okay, so between those two, which one's the largest side? We don't know. What are we going to have to do with this one right here? Take the square root. So let me show you to do that with these calculators since we've done them with the others before, but not with this one. Okay, your square root key might be around here somewhere for some of your calculators. Mine is right next to my 7 key. Right next to your 7 key, if you have one of the class sets, is an x squared. And above the x squared, do you see the light green square root key? Yeah. If you have one of your own, it may be in the same place, or it may be like right around here and you'll see the square root symbol. Okay, so since mine is green, I'm going to use my green key, second square root, and then it shows me the square root symbol. What was the number? 440 equals, and what does it come out to be? 20.9761. I'm going to round that to 21, or which one's bigger, 20, 29, or 21? 29. So this is the C. It does not matter from these two which one's A or B as long as C is 29. Why does C have to be 29? It's the biggest number, and C is always your biggest number. Okay, 20 squared for A plus square root of 440 squared for B equals 29 squared for the C squared. Does it matter the order in which you write these two? So if somebody flipped these two, does it matter? No, addition is commutative. All right, put that away. Either in your head or with your calculator, what's 20 squared or 20 times 20? 400. Plus, what's nice about the square root and the squared? So what's the square root of 440 squared? 440. And what's 400 plus 440?
840.
Okay. Equals 29 squared. Your squared key in your calculator is right next to your 7 key. Don't use your second. You just do 29 squared. And what does it come out to be? 841. Did they come out to be equal?
Yeah.
So would I say right triangle or not a right triangle? Not a right triangle. Questions? Okay. Find, and these questions are on the test, by the way, these type, where you have to find the value of one by using your square root key and then determine which one is C. Okay, find the value of X or Y, depending on what they're asking you for. Number 2, 3 and 4. Before we actually do them, I am going to quickly review over on this side here. How to find a missing side. How to find a missing side. So this all right here is going to be a review on how to find a missing side. First thing I want to write down is that all of these have to be right triangles. These 3 methods we're going to go over are only used when you're looking for a missing side on what type of triangle? A right triangle. Okay, first one I'm going to review is Pythagorean's theorem. Which is something you've learned before this class, whether it was last year or a previous year. Pythagorean's theorem. What is the theorem? A squared plus b squared equals c squared. Now, when you're looking for a missing side for Pythagorean's theorem, what do you need to know? You need to have how many sides? 1 side or 2 sides? You need 2 sides. In order to use Pythagorean's theorem to find a missing side, they need to give you 2 sides. Does it matter which 2 sides they give you? A and B, or B and C, or C and A? It doesn't matter. You can use Pythagorean's theorem to help you find your missing side. Do you guys remember this from a previous year? Yes or no? All right. Another method that we've learned just this year, this method is new, is special right triangles. Special right triangles. This is the lesson we did right before Thanksgiving break. 45, 45, 90. And who remembers how to label them? What these 2 are my congruent sides because it's an isosceles. What do I call these 2 legs? A and A. And the hypotenuse was not 2A, but A square root 2. Okay, and then the other one was not the 45, 45, 90, but which one? 30, 60, 90. Good job. 30, 60, 90. Does anybody remember which one was the 2A? That's your longest side. That's the one I like to label first. Which one is 2A in this picture? Hypotenuse. So you can see that both of the hypotenuses here have a 2. This is 2A, but this one's A root 2. Okay, the next side I like to label is my smallest side, which is A. And where does my smallest side located? Always opposite which angle? The 30. So opposite the 30 is here. This is A. And I call this my wonky side. What was this one? A square root 3. How many of you guys have those for the most part memorized? A few of you, good. You want to work on them, guys, because you need them by next week on the quiz on Monday and the test on block day. Okay, so what do we need in order to use special right triangles? We need triangles that have what special angles? 45, 45, 90, or what other set of special angles? 30, 60, 90. Would a 40, 50, 90 work? No, it has to be 45, 45, 90 or 30, 60, 90. Okay, questions? All right, our last one is the stuff that we learned right after break when we came back, and that's trig. Trig is short for trigonometry. You can write down trigonometry if you want. I'm just going to shorthand it to trig. And this is the SOHCAHTOA business, the sine, cosine, tangent. Okay, so if you had a picture like this, that is 50, this is x, and this is 12. Could you use SOHCAHTOA to help you find your x? Yes. In order to use SOHCAHTOA to find a missing side, Seth, get your head up off the desk, please. In order to use SOHCAHTOA to find a missing side, what two things do you need to be given? One angle and one side. So you need at least one angle, because they will always give you the 90. We're not counting the 90. At least one angle. I say at least because is it okay if they give you two angles? Is it okay if they give you both? If they do, does it matter which one you use? No. So you need at least one angle and one side. And if they give you two sides, pick a side. It doesn't matter. Same thing. All right. Questions on our three methods that we have, and all of these three methods will be on the test. So you can see why this is going to be a difficult test. You want to make sure you understand what each method is and how to use them to find your missing side. Pythagorean's theorem, if you have two sides given to you, use Pythagorean's theorem to find your third. Special right triangles. If you have a 45-45-90 or a 30-60-90, use your special right triangles to help you find the missing side. And if you have an angle and one side, use your SOHCAHTOA to find the missing side. Okay, questions? All right, let's try some examples now and figure out which method to use. Okay, first one, I'm going to draw a right triangle. Remember, all of these are for right triangles only. All of these methods here. Okay, 60, 30, 28, and x. Okay. Let's go through our list. What kind of triangle is this? Is one where I'm going to use Pythagorean's theorem to find the missing side? Yes or no? No, because I need two sides and I don't have two sides. Could I use my special right triangles? Yes, because it's a 30-60-90. Do you agree? Yes? Technically, if I wanted to, I could use SOHCAHTOA because I know one angle, at least one angle and one side. But I'm going to use the 30-60-90 to practice. Okay. Remember, we label. It's the picture's drawn different from this one, but it's okay. Which one is my 2A? What is that? Which one's 2A? The hypotenuse, the 28. Opposite the A is 30. Did they ask me for that one in this problem? I'm going to write it in pencil because did they ask me for that one? No, they asked me for x, and what is x in this picture if it's opposite the 60? A root 3. Again, the ones in pen are the ones that I need. I just put this one in pencil just because I'm used to labeling it, but technically it's not necessary. These two are the only ones I need. Which one am I going to use to help me find A? If 2A equals 28, what does A equal? How do you solve that? Divide by what? 2, and what does A equal? A equals 14. What does x equal if it's A root 3? What is it? 14 root 3. Now on test day, let's say they asked you for both of them. Let's say they called this y. I'm just going to put that here in pencil on the side. If they did ask you for this side as well, what would you say the answer is? 14, because on the test they will ask you for both sides. All right, questions on this one? Okay, number 3. (35°) y and 18. This is the side I'm looking for. Can I use Pythagorean's theorem? Yes or no?
No.
Can we use Pythagorean's theorem? You need 2 sides for Pythagorean's theorem. Can we use it? No, because I only have 1 side. Could I use my special right triangle if I need it to be 45, 45, 90 or 30, 60, 90? No, because that's not a special triangle. Can I use SOHCAHTOA if I need at least 1 angle and 1 side? Yes. So remember this, these are the ones I told you to do where you mark your angle with a pen or pencil. You put your dot on the angle that's given, other than the 90, and then you label these accordingly. They both look next to, so which one's adjacent and which one's hypotenuse? 18's hypotenuse, and y is the adjacent. And then we write down our SOHCAHTOA to help us figure it out. Which one here is adjacent with hypotenuse? Cosine? Adjacent hypotenuse? Okay. So cosine of an angle, always. So y 35 or 18? Cosine of 35 equals, luckily we have it labeled, so is it 18 over y or y over 18? Y over 18?
Is how you stop it.
Put them away. Take them off and put them away. All right. What kind of problem is this? Is this the easier one or the one that has the extra step?
The easier one.
The easier one, because y is in the numerator. Let's cross multiply. 18 times 35 degrees. So I wrote it wrong. Before I fix it, can I multiply 18 and 35? No. It needs to be 18 times what? Cosine of 35 equals 1 times y is just y. All right, is this ready to plug in the calculator? Yes, so turn your calculators back on if they've turned off. 18 times cosine of 35. 18 times cosine of 35. Hit enter. 14.7447368. Anybody get that?
Yep.
Does anybody have it in radical form? Like your calculator gave it to you in radical form? We're all good? Okay. Y equals nearest tenths. What would that be? 14.7 or 14.8? 14.7? Nearest tenths place. If it was to the nearest whole number, yes, it would be 15. But the nearest tenths place, we look here, the 7, after the 7 is a 4, so it's going to stay 7. Okay, number 4. Four, 12, and y. 4, 12, and y. Which method am I going to use here? Pythagorean, special right triangles, or SOHCAHTOA? Why can I use Pythagoreans here? Because they gave me 2 sides, right? It doesn't matter which 2 sides, they gave me 2. Remember, this is one kids always miss on the test because they forget, oh, I can use Pythagorean's theorem. It does not matter which one's A and B, but it does matter which one is C. Which one is C in this picture? The 12 is C because it's bigger than the 4. The Y, why is it the Y?
Because it's opposite the 90.
Opposite the 90. These are A and B. Does it matter which one is A and which one is B? No. 12 squared plus 4 squared is the same thing as 4 squared plus 12 squared. Go ahead and work that out. All right. 16 plus 144 equals y squared. If you don't plug this in the calculator, this is the one where you break it down, factor tree. Keep going. Check with your partner, see if you guys have the same answer. All right. What's 16 plus 14? 160. What do we do to both sides to undo the squared? Square root, because they are inverses of each other. We're going to talk more about inverses today. They undo each other. What do you have to do with the 160? Break it down. Did anybody use 20? Yes? And that's okay. Did anybody use 16 and 10? I'm going to use 16 and 10 only because I can see, and when I do the numbers in my head, I know already that 16 is a perfect squared. What's 16? 4 times 4? Now 4 and 4 are not prime, but can I stop because there is a pair? Yes, I don't have to keep going. 10 is 2 and 5. So I have 4 and 4, 2 and 5. What's coming out as a pair? And does it come out as 4 or 16? And 2 and 5 stay, and it doesn't stay as 2, 5. You multiply them together. What's your final answer? 4 root what? 10. All right, and this here is your answer. Got it? Anybody get that on their own? Yeah? All right. Next problem. Questions on this one before I move on? Okay. Write the ratio, and I'm going to make that plural, ratios for sine x, cosine x, and tangent of x. Sine, cosine, tangent of x. Okay. Here's the picture. All right, 6, 16, and 2 root 55. Now this is on your review worksheet today, and a lot of kids struggled. Only because we spend so much time reviewing how to find a missing side. That's what they were trying to do here. or they were saying, I don't know an angle, I don't know what to do. Are they asking you for a missing side on this one? Nowhere does it say find a missing side. And look at, are all your sides given? Yes. They want you to find sine, cosine, and tangent of what angle? X. So I'm going to label my angle X here. What is 6 in reference to the X? Opposite. What is 2 root 55? And what is the 16? And then I'm going to write this down to help me. And then I'm just going to find sine, cosine, and tangent of each one. This is the very first lesson that we had when I first introduced sine, cosine, and tangent to you. That's all you're doing. What is sine in words? Put it away. Okay, what is sine in words? Opposite over hypotenuse. It's already labeled, so 6 over what?
6 over 16.
6 over 16. Can we reduce that?
Yes.
2 goes into both. What is that? 3 over what? 3 over 8? Okay. Cosine X is adjacent over hypotenuse. You have it labeled. So what is that? 2 root 55 over what?
60.
Thank you. Can I reduce the 2 and the 16? What goes into both? 2. What's 2 divided by 2? 1. So you're left with root 55. What's 16 divided by 2? 8. So root 55 over 8. Is that okay? Can I leave my answer with the radical in the numerator? Yes. The denominator is where it's not allowed. Okay, next one. Tangent is what in words? Opposite over adjacent. So 6 over 2 root 55. Gosh darn it. Is that one allowed? No. Before you rationalize, it's easier if you can reduce to do that first. Does this reduce? The 6 and the 2. 6 divided by 2 is, and 2 divided by 2 is 1. This is on the test. How do I rationalize? What do I multiply top and bottom by? Root 55. What's 3 times root 55? 3 root 55. And because it's a pair, that's the whole reason why we do this. What's root 55 times root 55? 55. Can we reduce these two numbers? Are they reducible, the 3 and the 55? No. These two are reducible, but can I reduce a radical 55 with the regular 55? No, we cannot. This is the final answer. Questions? All right, take your packets out. Your Unit 7 Packet 1. Take out your Unit 7 Packet 1.
Take my notes. Take my notes.
I do. We are very cute. This is the packet you want out. It's not your periods packet, but it's still the right one, so please take it out while I find yours. Please stop, you guys. Yes. Thank you for asking. All right. This packet, write this at the top of your packet. It's due tomorrow, Friday the 30th. Write that down right now. This packet, we're done with it, guys. We're doing the, look at this. Again, this is not your periods, but this is what I've done with you guys. And if you look, a lot of it is filled in, meaning I've done all this with you guys already.
You said due Friday?
Tomorrow.
What?
Yes. This is the last worksheet here. I want it open. We are making a few changes, so I need you guys listening. Everybody listening? Okay, first change. Everybody here on the mid-review worksheet. Yes? Okay. Go right here. Classify each triangle as acute, right, or obtuse, and I should not have erased that much, but it's okay. Classify as a right triangle or not a right triangle. Just like we did in notes. Right triangle or not a right triangle. I'm going to tell you right now, out of the 6, there's only 2 that are right triangles. Out of the 6, there's only 2 that are right triangles. All right. So, right triangles or not right triangles, you're not worrying about acute or obtuse. Okay, flip it over to the back side. And I want us to cross out the last 2 on the bottom page, the 6 and 7. We haven't learned that lesson yet. We're going to be doing that later today. All right, so flip back over to the first page. We're going to start it together. What theorem, which rule is this? From the notes that we just took, is it Pythagorean, special right triangles, or SOHCAHTOA? They gave me 2 sides and asked me to find the third. Pythagoreans is correct. Does it matter here which one's A or B? Does it matter which one is C? Which one is C? The Y? And then here, does it matter which one you call A or B? No. If you do 5 squared plus 10 squared, that's fine. I'm going to put 10 squared plus 5 squared equals Y squared. What is 10 squared plus 5 squared? Equals Y squared. And then you do 100 plus 25, and what does that give you? 125 equals Y squared. I heard somebody say it already. What can we do with the 125? Has anybody done it already? 5 and or 25 and? I can't use 10 here. 5 and 25. Thank you. Was that Raymond?
Yeah.
And then 25 is what? 5 and 5. I have 3 5s. Is that enough for all of them to come out? No, but one set does, one pair. So what's my answer? 5 root 5. So Y equals 5 root 5. And it tells us there to leave in radical form, not decimal form. Okay, next one. Navarrete, tell me which one is C. The 6, the Y, or the root 85? The Y, because that's the unknown. Be careful.
Or is it root?
It's root 85 because it's opposite the 90. Okay, so that one's A, that one's B, or B and A, does not matter. 6 squared plus Y squared equals the square root of 85 squared. What is 6 squared? Well, Y squared is Y squared. What's the square root of 85 squared? 85. Inverses undo each other. And then what's your next step? Subtract what from both sides?
36.
The 36. Good job, guys.
My name's not guys. It's not.
Well, I'm calling you guys. Y squared equals 85 take away 36 is what? Thank you. 49. And then what do we do to both sides? Is 49 a perfect squared? It is. So you don't have to break it down. You can just do it in your head. What's the square root of 49? 7. All right. I'm going to set up this next one and let you guys finish on your own. Adam, which one is C in this picture?
61.
61. Do you guys all agree with him? Does it matter which one's A and which one's B? No. 11 squared plus Y squared equals 61 squared. What is 11 squared? I heard somebody whisper it. 121. 61 squared. You have a square key on your calculator. I don't know if I've showed you this yet or not. Clear it. 61, your squared key is right next to your 7 key. Squared, or for some of you it might be up here. 3721. Yes or no? Yes? So 3721. I'm going to let you guys finish it. Subtract your 121. And actually, I'm going to go next. I'm going to finish this one off only because I want to talk to you guys about what you can do in your calculator. What do you get here?
3,600.
Okay. When you square root, instead of breaking down right away, how can you check if that's a perfect squared? One, some of you can probably recognize whether it is or not, but do you know how to take the square root of that number? You do second square root 3600. What does it come out to be?
60.
So is that a perfect squared? Yes. So what does y equal? 60. You don't need to break it down. Now, let's say you did that on number 1, and you did, what was it? The square root of 125. Is that what we had on number 1? So I do second square root 125. I get, well, I forgot to change mine back. Okay, what was it? Square root of 125. I get 11.18 blah blah blah. What does that mean? Is 125 a perfect squared? If it gives me a decimal value, is 125 a perfect squared? No, which means you then have to break it down. And you have to do this and take out your pairs, and 5 root 5 is your answer. If you check it and you get a whole number, then you don't have to break it down. That's your answer. All right, I want you guys to continue working, collaborating with the people around you, checking each other's answers every now and then.